Hi everybody, hope that you're doing well. We're going to complete 8.1 where we have been looking at two additional methods of solving quadratic equations. The square root method and completing the square. And at the very end of the first video on 8.1 we looked at two examples to where we completed the square. And now as we go to the completion of 8.1, we're going to look at two additional examples to where we're going to complete the square. And the difference between these two as opposed to the two that we looked in the first video, we're going to have to eliminate the coefficient of x squared because its coefficient is not 1. So step number one that needs to be done with problem 3 as we're viewing this right now is we need to make the coefficient of x squared 1. So we're going to divide all of the terms on both sides by that coefficient of x squared 2. There, a second time, a third time, and a fourth. And we'll simplify and we'll bring this down to having x squared plus 3 seconds x negative 2 is equal to 0. So now the coefficient of the quadratic term is 1. Now we move into the process of completing the square. Step 1. We move the constant term over to the right-hand side. And so we'll have x squared plus 3 seconds x, leave some space, is equal, move him over and change his sign. Next step, take the coefficient of the linear term, the positive 3 over 2, write it over to the side. The step that we do with 3 over 2, we ordinarily divide it by 2 to begin off with. But it's a bit hard-pressed for us to divide this by 2. It would require a little bit more work. So instead of dividing by 2, we'll multiply the 3 over 2 by 1 over half. That's equivalent to dividing by 2. And we'll multiply those across, and we'll get 3 over 4. We tuck that. And we square it, and that'll get us 9 over 16. So we're going to take that 9 over 16, and we're going to add it to the left-hand side of this equation. And whatever we do to the left, we have to do to the right. So we'll add the 9/16 to that side as well. The trinomial now that we have on the left-hand side, as challenging that it might look to be, it is a perfect square trinomial. It will factor to a binomial square. That is exactly what we want it to factor to. The first term of the binomial is the variable x, and the last term is the rational number that we see inside the house here. Not him, but the quantity that was being squared, the 3/4. So we'll put a positive 3/4 there. That will be equal to the sum of these two values. Now once again, like we showed you on a prior example, both of these numbers that have to be added together are both positive, so we can utilize a shortcut and just think of 2 plus 9/16 as really 2 and 9/16 if we were to actually merge them or add them together. And with it looking in this way, we can now change this 2 and 9/16 to an improper fraction, which would give 2 times 16, 32, plus 9, 41 over 16. Again, the primary reason which allowed us to do this shortcut is that both of these terms had the same sign. If they would have had different signs, I wouldn't have done that. We would have gone through the effort of finding a common denominator. So now we have our perfect square on the left-hand side, and we have a real number on the right-hand side. And now we'll use the square root method. We'll find the square root on the left-hand side, which is simply the binomial of x plus 3/4. Then that will be equal to positive or negative radical 41 over 16. Come back to the left-hand side and bring down x plus 3/4, and that will be equal to plus or minus, split this radical expression up because we can't have a fraction in the radicand. So we'll have positive or negative root 41 over root 16. Let me just kind of erase some things up above right here because I've got limited board space and I want to make sure that there is no doubt about what we're going to do. So I'll just recopy that x plus 3/4 up here, and that will be equal to positive or negative root 41 over the radical of 16, which is representative of a rational number. Its root is over 4. And now we'll move the 3/4 from the left-hand side over to the right so we can find our two values of x. And we'll have x is equal to, change of sign, negative 3/4 plus or minus root 41 over 4. And we are able now to combine these two expressions together because the denominators are like, and our final answer will be x is equal to negative 3 plus or minus radical of 41, the whole thing written over that common denominator of 4. And we'll just circle that, and that would be the answer for that quadratic equation using completing the square. Now let's do one last one to where we're going to have to get rid of the coefficient of the quadratic. Number 4, 3x squared negative 9x positive 8 is equal to 0. Can't have a coefficient other than 1 there. So we'll start off by dividing every one of the terms by 3. And that'll get it down to x squared. It just happens to divide nicely there. Negative 3x. Not so nicely here, just leave that positive 8/3, and that will be equal to 0. Next, move the 8/3 over to the other side. So we'll have x squared, negative 3x, leave a space, move him over, he'll become a negative 8 over 3. Now we'll come back to the left-hand side and take the coefficient of the linear term, negative 3, and we'll divide it by 2. I could have as well multiplied it by 1/2 like I did on the prior problem, but it isn't necessary on this one because this was an integer, and it's just much simpler to just show that it's going to be divided by 2. Now we can't literally divide it, so we'll just let it be that improper look. Tuck that little answer, and we'll square it. And that will give us a positive 9 over 4. So we're going to take that 9 over 4, and we're going to not only add it to the left, but we're going to add it to the right. On the left, he is a perfect square trinomial. And the binomial square that we'll derive, we'll start off with x, go right over here to this quantity that is in the parentheses, not him, this guy. He becomes our second term of our eventual binomial square. Negative 3 over 2, that squared is equal to this result right here. Now, I know some people, when they combine these two, they'll kind of combine it right in this area. I'm not going to. I'm going to kind of push this problem off to the side a bit. Negative 8/3 plus 9 over 4. And let's just methodically identify a common denominator, rename, and get our little answer. The least common denominator for 3 and 4 would be 12. 3 divides into 12 4 times. 4 times a negative 8, a negative 32. 4 divides into 12 3 times, and 3 times 9 is 27. Negative 32 plus 27, all of that over 12. And that'll get us a negative 5 over 12. That becomes the real number that is on the right-hand side. I'm just going to erase this information right here, just so we have a little bit of room in case I'm going to need it. Now we'll find the square root of the left-hand side, and that'll give us x minus 3 over 2. And on the right-hand side, that will be equal to positive or negative root negative 5 over 12. So now we'll bring down the left-hand side once more. And that will be equal to positive or negative root 5/12 times root negative 1. Now folks, here's what I'm going to do with the limited space that I've got as we just kind of step back and look at this. We know that this negative 1 is going to be translated to the variable I, the imaginary unit. That the radical of 5/12 is certainly going to have to be simplified. There's a few different things that are going to have to be done with this. So I'm going to set up the next steps somewhat like this. We're going to bring down the x minus 3 over 2. And that's going to be equal to positive or negative. Now we're going to bring in the translation for the radical of negative 1, which is I. And then at the same time doing that, I'm going to split this guy up. Plus or minus I multiplied by the radical of 5 over the radical of 12. Now I'm going to erase some information up here. And I'm going to bring this x minus 3 over 2 up here is equal to plus or minus I. And I'm just going to kind of let that rest. Yes, I could begin to do some things right here with this, but I'm going to pull this radical of 5 divided by radical 12. I'm going to kind of pull it off to the side. Because there's a few things that we need to do to this to get it simplified so that we can then take its result and put it right after this imaginary unit. One thing we're definitely going to have to do is we're going to have to rationalize that denominator. But this denominator is able to be simplified first. No, it's not a perfect square, but it's able to be simplified. So I'm going to bring down that radical of 5, and we're going to split up that radical of 12 by using the product rule of radicals. The largest perfect square factor that 12 would have would be a 4. So that'd be 4 times 3. And that's going to build this now to the radical of 5 over 2 root 3. Radical of 4, 2 root 3. Now we'll rationalize this denominator. The 2 doesn't need to be rationalized. The radical of 3 does. So we'll get a times sign ready, put a bar. We have the radical of 3 here. To make this rationalized, we're going to have to multiply this denominator by another radical of 3. So we'll have a 3 squared in essence. So we'll multiply the bottom by the radical of 3, and what you do to the bottom, you do to the top. And that will come down, and we'll then have the radical of 15 over 2 times the radical of 9. That will leave us with then the radical of 15 over 2 times the root of 9, which has now become rationalized, which would give 3. And we'll then have the radical of 15 over 6. Now you see the room, the space that we needed. I didn't want to necessarily do it here. I could have. Now we're going to bring that radical of 15 over 6 up here. Place that right here. It's been simplified. And now we'll move this negative 3 over 2 over to the other side. And we'll get x is equal to a positive 3 over 2 plus or minus I multiplied by the radical of 15, and that is written over 6. And there is our answer. No, we do not need to find a common denominator because we wouldn't be able to actually add those terms up there any further than what we see it there. It's fine to leave it in that way. As a matter of fact, it is that way because we are dealing with an imaginary number, a complex number, and we want to make sure that that answer is written in the standard form of a plus bi. There's your a, plus or minus, there's your bi. So we have our answer, and it's good to go. It required a little bit of work, but we were able to do it. So that's solving a quadratic equation by completing the square. Now I want to make a comment about completing the square before we leave it and move to a couple of application problems that we're going to deal with. So I want to mention this to you. Completing the square is not a very common or popular method to use to solve a quadratic equation. And it's especially not common or popular when the coefficient of the quadratic term of that quadratic equation is not 1. When it's not 1, it sometimes can be a cumbersome process to go through. Example, problem number 4, the one that we just finished doing. That was cumbersome to go through and deal with. There is a better method ordinarily to solving quadratic equations than completing the square. But there are reasons why we look at completing the square, and we'll see some of those reasons as we move further along in the course. But I wanted to mention that. It is not a very common method of solving quadratic equations. But it's part of the curriculum, so we looked at it. Now, There's two application problems that we're going to look at, and we're looking at them both on this area on my wall. The first application is dealing with a mathematical model. We've already done a problem that has dealt with a mathematical model, and we're looking at another one. It is an application that is dealing with compound interest. And the formula for compound interest is A for amount. Amount is equal to the principal multiplied by the quantity of 1 plus rate taken to the exponent value of time. So the compound interest formula certainly makes use of principal, rate, and time in its formula, but it's positioned differently and it looks differently. This is the model that we're going to be taking a look at to solve the compound interest problem that we're going to be dealing with. Now, briefly, the camera doesn't need to be on me right here at this point, but I do want to define what is meant by compound interest. Very simply, compound interest is interest earned on top of interest that has already previously been earned. Now, that's a little bit different when I say interest earned on top of interest that you have already earned. Let me give just a quick little example. I'm not going to put anything anywhere on the board, but I'm just going to give you a little bit of an example. Let's say you invest $1,000 into an account, and it's going to earn compound interest. And let's say the interest rate that you're earning on that $1,000 investment is 5%. You let that money stay in the account for a year to start off with. At the end of the year, you will have earned an interest off of that $1,000 of $50. How did we get that 50? You multiply the original investment of $1,000 and you multiply it by the interest rate of 5% expressed as a decimal, 0.05. If you multiply 1,000 times 0.05, you'll get $50. $50 is the amount of interest that you would then earn after a year on that investment. So people, at the end of the first year, you now have in your account $1,000 plus $50, or $1,050. Now as you move into year number 2, your brand new amount that you have in your account is $1,050. Interest added to the original investment. Now that money stays in the account for this second year, and at the end of the year, you're going to earn additional interest. How would that interest be computed? You take your balance that you have in the account, $1,050, and you multiply it by 0.05, and that's going to give you more interest that you're then going to add on to that $1,050, and so on, and so on, and so on. It's interest earned on top of interest already earned from an investment. So we're going to use this formula to answer the following question. And here's the question. You invested $3,000 in an account whose interest is compounded annually. The interest is going to be computed after each year. It's computed, it's compounded annually, yearly. At the end of each year, interest will be calculated. Whose interest is compounded annually. After 2 years, the amount or balance in the account is $4,320. $3,000 is the original investment. $3,000 is your principal. After 2 years, your time. It's going to be held in the account for 2 years. And after 2 years, the amount or balance in the account is $4,320. So we know him, we know him, and we know him. Question, find the annual interest rate. They're wanting us to find R. So just a little item that I'm going to put right down here in this spot. They want us to find the interest rate. Our answer will be a percent. Rates in banking are expressed as percents. So our rate that we will eventually come up with will be a percent. So we're now going to turn our attention here, and we're going to begin by writing down our model. Amount is equal to principal times the quantity of 1 plus R to the N. To the T, I'm sorry. I'm thinking ahead. Now we're going to substitute the information in our problem, and then we're going to go about the business of solving the equation. The A is the amount of money that is going to be in the account after 2 years. And Kristen will just kind of show that problem up there. 4,320 is the amount. So that's going to be positioned right here. And that's going to be equal to the principal, the original amount of the investment. And that original amount of that investment was 3,000. So the 3,000 goes here. Times the quantity of 1 plus R to the time element. And the time element is going to be held in the account for 2 years. Now, we want to get this perfect square right here. We want to get it isolated. We've got to get rid of this 3,000. This 3,000 is a factor. There's a time sign right here. So we're going to divide the right-hand side by 3,000. And we're going to divide the left-hand side by 3,000. We're going to bring that equal sign down. We're going to be left with the quantity of 1 plus R squared on the right-hand side. And on the left, I'm going to do a little bit of simplifying, and then we'll do more simplifying off to the side. Both the numerator and the denominator end in a 0. I wish both of them ended in more than 1 0, but they at least end in a 0. So we can actually reduce the numerator and the denominator by 10 and just cancel out those zeros. And now 432 over 300, we're going to reduce as far down as we can. And I'm going to get the fraction bar ready. And I'm not going to do any work over here. We're going to do it over here. 432 over 300. I'm going to bring down sort of an elongated fraction bar. And I'm going to hold off on 432. Let's take care of the denominator of 300. That should be easy to prime factor. And I'm going to prime factor. 300 ends in 2 zeros. That means 300 has a 100 as a factor. It's 100 times 3. I'll just kind of note that right here. I'm going to bring down that 3 because he's prime. 100 is 10 times 10. And that 10 is 2 times 5, and that's 2 times 5. So we have the prime factorization of 300 completed. Now let's do 432. And 432, I'll do an upside down division for that. We can divide it by 2. 2's our first prime number. That would be 2. 2 would go into 3 once, with 1 left over. That'd be 216. We can do 2 again. That'd be 2, and that would be 108. We can do 2 again, and that would get it down to 54. We can do it by 2 again, and that'd be 27. Now we'll go to 3. We'll have 3 and 9, and 3 and 3. And so we'll have on the top a total of 4 factors of 2. I could use exponents, but I'm not. And 3 factors of 3. And now we'll cancel where we can. We can cancel 1 pair of 3's. We can cancel 2 pair of 2's. And we'll have on top, we'll have a 4 times 9, which will give 36 over the bottom 25. So we'll transfer that 36 over 25 over here. Now you might find it a little bit easier to put the perfect square on the left-hand side, so I will. 1 plus r, that quantity squared, is equal to 36 over 25. Now we have a perfect square is equal to the real number 36/25. We'll find the square root of the left, and we'll have 1 plus r is equal to. Now I want to pause for a second. Let's not lose sight of what we are really being asked to find. We're being asked to find r, an interest rate. No interest rate can be negative. So when we come over here to this right-hand side, it is not necessary, nor do we want to really, we don't want to identify the negative square root of 36 over 25. We can if you want to, but it's going to be meaningless. I'll go ahead and show it as that. Plus or minus the radical of 36 over 25. And that will come down, and we'll have then 1 plus r is equal to positive or negative. Both 36 and 25 are perfect squares. They'll both come out of the house, and we'll have plus or minus 6 over 5. So now, we'll set up 2 equations. One of them will say 1 plus r is equal to a positive 6/5, or 1 plus r will be equal to a negative 6/5. We'll put it right here. 1 plus r is equal to a positive 6/5, or 1 plus r is equal to a negative 6/5. I'll go ahead and do this one first because this one is going to be rejected. Negative 1 is equal to negative 1. And we'll have r is equal to, you can just kind of stop the process right here, because a negative 6/5 combined with a negative 1 is just going to make it further negative, and the answer cannot be negative. No interest rate can be negative, so that one's going to be rejected. This one right here, we'll bring down the r and let it equal 6 over 5, and we'll move this one over to the other side, and when we move it over, it'll change its sign. We'll then have r is equal to 6/5 minus, well, the value of 1 written as a fraction with a like denominator of 5 would have to be minus 5 over 5. And that will then give us r is equal to 1 over 5. 1 over 5 is our rate, but it's the fractional equivalent of the rate that we want. So we'll have to change that 1/5 into a decimal so that we can then get it into a percent. Now your calculator will do it. Let me just kind of put that R is equal to 1/5 right there for a moment. If we change that 1/5 to a decimal, we'll divide that 1 by that 5. We'll put a point after the 1 and add a 0 and bring it up, and it'll go 2 times exactly. Now we simply take that 0.2 and move that decimal point over to the right twice, and we'll have our percent and the interest rate. Finally, is a 20% interest rate that bank would be giving that client that invested that amount of money. A little bit of work. We'll call it on this one right here. I don't want to lose this video whatsoever, so we'll just call it at this point, and we'll get the other one in. You take care for right now. Goodbye.